Over 41,000 airports are scattered across our planet, housing more than 23,000 airplanes. Every day, everywhere, air traffic controllers keep pilots and passengers safe from not only collisions, but also wake encounters, which can be just as dangerous.
Behind an aircraft, you have these counter-rotating vortices. There is this invisible wake with this upwash portion on the outboard part of that counter-rotating and then a downward on the inside. Think of them as horizontal tornadoes.
Engineers at NASA's Armstrong Flight Research Center are testing new technologies and methods to help aircraft identify where wakes are and avoid them, or even ride them.
It's really biologically inspired. If you've ever seen a flock of geese, the reason they fly in a V is that the trailing birds are really gaining efficiency from the lead bird by flying in the upwash caused by vortices generated by the wing in flight.
So if you fly in the area where the air is rising, it's like gliders that soar in thermal updrafts. You can extract energy from that. The ultimate objective of flying in the upwash portion of the wake is to reduce the fuel burn and the emissions of the trailing airplane.
Okay, pilot's airplane. Copy that, then let's go ahead and start moving on to card 9 and give 808 the lead.
We would begin first by positioning ourselves about 4,000 feet back and then to the side of and above where we estimated where the wake would be.
EPA is engaged.
TCS release. Saudi engaged. Control command is climbing. We're getting some long-term oscillations, so I think we're close.
We're going to do a 5-foot step in to crash track at minus 75.
Okay.
Activating new command 3, 2, 1, activate.
Getting a little bit of buffeting, very slight. Can you guys feel that I'm back?
Just a little bit, but yeah.
What we're noticing on this flight, I think, is that the power required to maintain a constant position when our wingtip is in the wake is less than it is required when we're not in the wake, which means we're going to save fuel, that's the idea.
I was even surprised by some of the flight dynamics and things that we saw in flight. There really is no substitute for taking an experiment to flight. You learn things that sometimes you don't want to learn, but you also see the beauty of the real atmosphere and the challenges that are associated with real vehicles being flown by real systems and real pilots.